In this video, we're going to go through the method for solving rational equations. Now, I've written out steps that we're going to use to kind of approach each problem. The first thing we're going to do is factor the denominators, if it's possible to factor the denominators. Then we're going to find the LCD. From there, we're going to multiply each term by the LCD. Our goal is to cancel the fractions. After we've done that, we're going to solve the equation. And then we're going to take our solution and check it to make sure that we have no issues with it in the original problem, in particular, so that we don't get zeros in the denominator. Okay, so let's go through an example here. In this particular example, I have no denominators to factor. So what I'm going to do is go ahead and just find the LCD. I see that 2x goes into 4x squared, the second denominator. So I'm really just going to compare the second denominator to the third denominator. So the 4 and the 3 tell me I'm going to need an LCD of at least 12. And because the highest variable exponent is x squared, that's going to compose the LCD. So 12x squared is the LCD. So what I'm going to do is I'm going to multiply each term by 12x squared. And I'll do this regardless of whether or not each term has a fraction. We're going to always multiply each term by the LCD. Now, the whole purpose of this is to cancel fractions. So what I'm doing is I'm kind of thinking of this as 12x squared over 1. And my goal is to cross-cancel the 2x with the 12x squared. In other words, 2 goes into 12 6 times, and x goes into x squared, and leaves me with an x. So I'm going to take that remaining result, 6x, and times it by 5, which will give me 30x. For the second denominator, 4 goes into 12 3 times. And in this case, the x squareds completely cancel. So I'm left with 3 times 3, or 9. Last LCD here, we're going to cancel the 3 with the 12. That's going to leave us with 4. The x goes into x squared 1 time, leaving me with 1x. And 2 times 4x leaves me with 8x. Okay, so now I have an equation that I can solve as normal. So I'm going to go ahead and subtract 30x to get the x's to one side. So that's going to give me negative 22x. Then to solve for x, I'm going to divide both sides by negative 22. The negatives are going to become positive, but I can't simplify this fraction any further. Now, I'm going to make sure that this does not give me 0 in the denominator. And as you can see in blue, all of my denominators, the only thing that would give me 0 in those denominators would be 0 itself. So x can't be 0. I can see that from the beginning. Therefore, this solution is a good solution for this problem. All right, let's try this example. So in this case, we actually can factor the denominator. I'm going to go ahead and factor this middle fraction here. And if I use the x method approach, what would go at the top of the x would be negative 16. Bottom of the x is negative 6. Two numbers that multiply to be negative 16 but add to be negative 6 are negative 8 and positive 2. So this is going to factor into x minus 8, x plus 2. And everything else will stay the same. Well, that's a pretty handy denominator because the other denominators have those two factors. This one has the x plus 2. This one has the x minus 8. So that's going to be the LCD. X minus 8 and x plus 2. So I'm going to multiply each term by x minus 8, x plus 2. And I know it's a little bit annoying writing it out. It's usually worth it, just so you don't forget anything. All right, the whole goal is to cancel fractions. So in this first one, the x plus 2 cancels, and I'm left with 5 times the x minus 8, which will distribute. The second fraction, everything cancels, and we're just left with 2. Third fraction, the x minus 8 cancels, and we're left with negative 4 times x plus 2. And this is why I usually save the distribution, because right here in this last term, that negative, you may have accidentally forgotten to distribute it, but now I won't. So I'm going to distribute 5x minus 40 plus 2. Here we'll distribute the negative 4 and get negative 4x minus 8. All right, so let's combine the like terms over here. Oops. So negative 4 plus 2 is going to be negative 38. And I'm going to go ahead and add 4x to this side. And at the same time, I'm going to go ahead and add the 38 to the other side. Save myself an extra step. So that'll be 9x, that's gone, equals 46. Dividing both sides by 9. I see I can reduce this. Let's see, is 46 divisible by 3? The way I can check that is on the calculator, of course, but if I add the two digits together, I see that that adds up to 10, and that is not divisible by 3. So then that's my final answer, 46 over 9. Oh, wow, I wrote it backwards. That's funny. Let me fix that. Okay, now coming back up to the original problem here in blue, I want to make sure that I have no issues with my answer. So I'm going to kind of make sure that I know what x can't be. And in this, I could see, based on it factoring, that x can't be negative 2 or positive 8. And my answer is neither of those, so we're okay. All right, let's try this example. Again, no factoring on this one, so let's just jump to the LCD. I see I have one number, so I'll just add that to the LCD. And because x goes into x squared, I'll use the higher exponent for the variables, so I'll use the x squared. And I'm going to multiply each term by 4x squared. Okay, so let's do some reducing. On the first term, the x squareds will cancel, and I'm left with 4 times 1, which is 4. This second term, the x reduces with the x squared and leaves me with 1x. So I have 1 times 4 times x, so I'm just left with 4x. And here on the last term, the 4 reduces completely, and I'm left with 3x squared. Okay, now here's what's special about this. I actually have an x squared term that I need to solve with, which means I have a quadratic equation. In other words, in order to solve this, I'm going to need to factor. But before I can factor, I've got to get it equal to 0. So I'm actually going to subtract 4x and 4 from both sides. So this is going to leave me with 0. And on the right side, I'm going to have 3x squared minus 4x minus 4. And none of those combine, since they're not like terms. All right, so I'm going to factor this. We'll use the x method. So at the top of the x, we're going to have negative 12. The bottom of the x, we're going to have negative 4. Negative 12 comes from multiplying the first and the last terms. So two numbers that multiply to be negative 12, but add up to be negative 4, well, that'll be negative 6 and positive 2. So I'm going to go ahead, oops, sorry. Oopsie, there we go. I'm going to go ahead and rewrite this using the 6x and the 2x instead. And I'm going to go ahead and factor by grouping now. So in this first term, I'm going to factor out 3x, and I'm left with x minus 2. Second group, I can factor out 2, and I'm left with x minus 2. So my blob is x minus 2, and I'm left with 3x plus 2. All right, so setting those two things equal to 0, I'm going to go ahead and do that over here. So x minus 2 equals 0 is going to give me x equals 2 as one solution. And 3x plus 2 equal to 0. I'm going to get 3x equals negative 2 or negative 2/3 once I divide. Oops, shift this up as my second solution. Now, I'm going to go back to the original and make sure I have no issues with those solutions. I see in my original problem that as long as x isn't 0, oops, we're good to go. And since neither of my solutions are 0, those are my solutions. All right, let's try this example here. I notice that the last fraction can be factored. So that's the first thing I want to do. That happens to be a difference of squares. So I'm going to factor it into x plus 3 and x minus 3. Again, very handy because that happens to be the factors that match the other two fractions denominators. So I've just found the LCD since these are what are in common with the other two. So the LCD is x plus 3, x minus 3. So I'm going to multiply each term by the LCD in order to cancel the fractions. So in the first term, the x minus 3 cancels, and I'm left with x times x plus 3, which I'll take a moment to distribute in a second. The second term, the x plus 3's cancel, and I'm left with 2x times x minus 3. And the last one, everything cancels, and we're just left with 18. All right, let's distribute now. So this first term, I get x squared plus 3x. In the second term here, I'm going to get 2x squared minus 6x, all equal to 18. All right, let's go ahead and combine like terms. So the x squareds are going to add up to 3x squared. The x's will add up to negative 3x. And again, I have a quadratic, so I want to get this equal to 0. So I'm going to subtract 18, which doesn't combine with either of those terms, but it does leave me with 0 on the right side and something I can factor on the left. All right, so first thing I notice is there's a GCF of 3. So I'm going to factor that 3 out. And I'm left with x squared minus x minus 6. Now, at this point, if you wanted to, you could actually divide the 3 out completely and have it cancel. But for right now, I'm just going to leave it alone. All right, I'm going to use the x method to finish factoring this. So at the top of the x is going to be negative 6. Bottom of the x is negative 1. Two numbers that multiply to be negative 6 but add to be negative 1, that's negative 3 and positive 2. So this is going to factor into x minus 3, x plus 2. Now I'm going to set these pieces equal to 0. Notice I'm not going to set the 3 equal to 0 because that would make no sense. 3 doesn't equal 0, so I'm just going to ignore the 3. And here I'm going to get x equals 3 and x equals negative 2. And I'm going to check these to make sure that neither of them give me an issue in my original problem. So I'm going to come back up here to the top, and I notice that in the original problem, x can't be 3 or negative 3. Okay, well, I happen to have one solution that equals 3. So this one no longer can work because it's going to give me 0 in the denominator, which I'll abbreviate. Therefore, the only solution that'll work is x minus 2.